Welcome everybody. Welcome to a new episode of AZ Security. My name is Dinant Paardenkoper. I'm working as a cloud architect, and today we have the topic confidential computing, something completely different. Today I have a special guest, and that is Simon from Microsoft. Simon, could you introduce yourself, please?
Sure. Yeah, hi everybody. So my name is Simon Gallager. I'm a technical program manager in the Azure Confidential Computing product group. So I spend kind of half my time working with customers who are adopting the technology, kind of helping get POCs off the ground, and then the other half working with my colleagues back in the rest of Microsoft on kind of feature development and really just trying to make sure we've got a really tight feedback loop from kind of field product back to engineering. I've been with Microsoft for just about 3 years. Prior to that, I spent quite a lot of time with a Swiss bank as a cloud CTO. And I've worked across a number of different industries, telco, media, all the way through to sort of financial services and several other along the way.
Wow, that's quite a long list. And confidential computing, how long do you work with this technology?
So I started looking at this in my previous role. We'll look at this in a minute, in the kind of very early days of confidential computing as a technology. So probably about 6 years, I would say.
6 years. Wow. Yeah, that's quite a long time. I've
I
worked with.
think it's only been around for 10. So yeah.
Well, I've worked with the private preview when Microsoft released it, and with one of the companies which was involved with the private preview in the Netherlands. So we've seen it developed to the stage where it is now. So that's looking amazing. But before we dive in, can you short explain what is confidential computing?
Sure. Yeah. And look, so I guess I always kind of preface this that, like any program manager at Microsoft, I have a slide with about 5 million, sorry, a deck with about 5 million slides in it. So I'm more than happy to jump around as we need to. So I always like to start with kind of this view, which is really a stack representation of how confidential computing right now is a kind of opt-in technology in the Azure platform. At the very bottom, we've essentially got the kind of legal and contractual commitments between Microsoft and all customers. These are around where we share, how we handle sort of data privacy and compliance, and that's common for all customers.
Okay.
I guess the more relevant part is the next part up, which is really what we see as controls. Now, if you're familiar in a regulated industry with the term controls, these are essentially requirements that are handed to businesses by their own regulators or maybe government entities or some kind of oversight body around the things that organizations have to do. So in terms of a kind of public cloud engagement, these are typically the controls that you give to Microsoft to operate on your behalf. So they range from everything that handles all the physical elements of the cloud platform, from data centers all the way through to kind of networks and even background check of staff, etc. And then on top of that, we have our control plane, which is what we use to orchestrate all of those physical elements of the Azure platform. Now, those are all independently audited. So, similar to many regulated customers, we have our own auditors that come in on a periodic basis to review how we are operating that. And those reports, for example, SOC 2 reports or FedRAMP reports for the US federal government, are surfaced up through the Azure Trust Center. And those docs are available there. So the next layer up that most customers interact with are the customer tenant controls. This is where you define, for example, your Entra presence, or formerly Azure Active Directory. This is where you define role-based access control. You can define things like Azure policy, subscription structure management groups, and you can then leverage all of the security tooling and logging to provide data that you can integrate into your own controls that you evidence to your own regulators. Now,
that's sort of the Azure policies and that kind of guardrails, right?
Yeah, that's right. So yeah, guardrails are a really good way of thinking about it. This is around how you can place kind of identity, network, and policy guardrails around everything that your organization is deploying into Azure.
Okay.
So on their own, those 4 layers are essentially what Azure has developed across the last 10 to 15 years. Already a formidable kind of defense in depth technology stack and operational stack. But for some organizations, they want to go further, and there's a reason they want to go further. Is one, because the kind of industry is moving on and more technology is becoming available, but also privacy regulations are becoming much more stringent in certain markets. So today we kind of represent confidential computing as on top of the stack here, because it's a kind of opt-in technology. It's something you choose, you make a conscious decision to deploy. Now, in reality, the technology that enables confidential computing is really baked into the silicon, right? These are new silicon features of the CPUs that we deploy into our regions globally. So, over time, we expect to see that kind of blend much more into the rest of the Azure platform. But you might ask, what is confidential computing? I think data at rest and data in transit encryption is a fairly well done story. Everyone kind of gets what that is, and that's the only reason that's now almost the default for everything is because that technology has become ubiquitous and easy to consume, so it's almost a no-brainer to do so. But protecting data whilst it's in use has traditionally been a really difficult computer science problem, if you want to put it that way. You need to have generally data in the clear to be able to compute against it. There are some kind of abstraction methods for doing this, but if you want general purpose compute and be able to compute upon it, you need to have it in the clear. So confidential computing is a way of doing that, but also encrypting that data once it's outside of what we call an enclave or trusted execution environment. So we encrypt data when it hits physical RAM chips, and we protect CPU elements whilst things are being processed. So that allows us to protect against a couple of different threat vectors, and it's always important to think in terms of threat scenarios when you're looking at these technologies. What is it you're trying to protect against? So the obvious one are external hackers, or external people with ill intent. That first slide showing that stack of controls is already a fairly significant set of controls, and that's further enhanced with confidential computing. But it would be kind of naive to say that first part of the stack is has no potential to be exploited in kind of corner cases, or despite all the best in class security that Azure does. So we can use confidential computing almost as a kind of backstop by saying that whatever happens, we wrap that customer in encryption based on hardware, and we can then use that to mitigate any of those type of attacks.
I agree. Yeah.
Yeah, and obviously insider threat has traditionally been a common scenario in healthcare and financial services. This is where administrators, your own IT staff, typically need to hold a fairly high level of privilege to do their day job, right? To debug things, to fix things, to monitor things in some cases. There are vectors where potentially you want to protect against those admins either abusing those privileges to try and exfiltrate data or do something malicious, despite all of your own background checking and oversight that you do. But I think more commonly that we see scenarios within customers is that you want to be able to protect against those credentials being misused by somebody else. So, for example, if one of your administrators has one of their administrative credentials phished, stolen by a third party, we do typically see those type vectors being used for attackers trying to pivot around customer platforms. So, and we can use confidential computing as a way further to protect some of that. And then really kind of third party access is really this kind of multi-party scenarios, which is actually kind of new business scenarios that are opened up by confidential computing. If you ever had to do a kind of mergers and acquisition type thing, or maybe an organization that's trying to cooperate with organizations that would typically be competitors, sharing data in those scenarios is really difficult. What you end up with is a lot of legal work, that data has to be redacted, and by the time you get a redacted data set, sometimes the value is much diminished. We can use confidential computing as almost like a black box that everybody contributes their data into, but no one full party has access to that full set of data. So confidential computing, the silicon is really kind of providing the underlying infrastructure to enable that, and then you can build software solutions on top of it to get much more granular and fine-tuned access control.
Yeah, I think this is one of the cool, amazing features where you had in the past, you have some data sets that should be exchanged, and now you have possibilities. Just say like, well, here's the data. You can enable people with permissions and that kind of stuff. They can do their work, but instead of transferring all the data to and from each other, there's now a place that you can reuse, right? With
Yeah, that's right. And if you look, so we kind of recently announced our clean room scenario, which is currently in preview, which is very much that. It's a software stack that's built on the confidential computing infrastructure. You can use that and some kind of adjacent ecosystem tools to provide really fine-grained access control. Party A can't access Party B's data, or even down to certain elements of data within that stack.
Cool. Yeah, that's amazing, especially for universities or other organizations which have a lot of innovation power or have to do research with each other.
Yeah, absolutely. So, and this is really based on what we call a trusted execution environment. The key point here is that it's based on hardware-based and a tested trusted execution environment. And this really important distinction that we'll look at in a moment. But you use that kind of hardware root of trust, which is baked into the silicon, to build out kind of integrity and confidentiality guarantees on the platform. This isn't just Microsoft. Microsoft are part of the Confidential Computing Consortium. Even with organizations you would typically see as our competitors here, we're really trying to make sure we're driving an industry standard for confidential computing based around that hardware, the hardware-based trusted execution environment. Because the worst thing in the world will be is if everybody uses the same term but goes off to do something different. So this is really where we, and I think really the majority of kind of hyperscalers out there are looking to align along those things. And obviously there are various ISVs that are providing software solutions that complement that, which is a really cool place to be. There's a really active marketplace of ISV solutions to enable some of those higher level functions built on the low level confidential computing constructs. So confidential computing has been around for just over 10 years. I mean, I think as we said at the opening, I've probably been working with it for about 6, but started out in the very early days from some kind of research work, with the initial offering to market with sort of Intel's SGX product, which has really been built on now with some of the further products from AMD, which is their SEV SMP product, and Intel's upcoming TDX or Trust Domain Extension product. And we've expanded out into kind of container services and also into GPUs, which we'll look at in a moment. But if you're going to kind of look at conceptually what a trusted execution environment is, I always try and use a physical example to ground this. And if you've ever watched The West Wing or any of those kind of US dramas, or something where something needs to be discussed in absolute secrecy, this uninspiring shipping container is an example of a SCIF, or a sensitive compartmented information facility. So these are kind of common in government and military organizations. There are slightly derived versions of this in normal commercial industry as well, but the concept is it's kind of an isolated space. It's protected, that you'll see there's kind of hardcore access control on the doors. You could imagine guards standing outside this. It's tied into alarm systems, but it's also complemented with emanation protection systems, which in reality for this would be like a Faraday cage built inside here, and soundproofing to stop people listening from the outside in, but also to stop any kind of electronic emissions, maybe rogue Bluetooth or Wi-Fi signals or something coming from inside that shipping container. It really yields you this kind of conference room setup on the right-hand side. Everybody in that room can discuss everything freely. The secrets can be put on the table, but anytime data needs to leave that room, it needs to be encrypted in this case, it would be maybe put in a suitcase that's padlocked to someone's hand before they leave the room and encoded. But it's only ever discussed in the clear inside that room. Now, in the kind of digital world, the equivalent of that is this trusted execution environment concept. So it's there for a couple of reasons. One, it's there to kind of reduce down attack surface. So it takes away some of the stuff that's provided by the cloud provider, kind of abstracts it, gives it to the customer, but ensures that it's based on this kind of hardware root of trust, which are certificates that ship in a kind of TPM that's baked into the hardware from the CPU provider. So this is something Azure doesn't have access to or the ability to. This is stuff that's protected by the hardware itself. We as Azure run the kind of hypervisor and host OS on top of that, which is our Azure virtualization layer. And then when we stand up customer VMs on top of that, customer's guest OS and the code and the data that resides inside it, kind of represented by this kind of blue bounded box here, is protected by encryption. Okay, and that, you'll see the kind of padlock here represents that. What it really means in practical terms is if the worst were to happen and that kind of stack of controls on the first slide were breached, and an attacker lands here at the hypervisor or guest OS layer, if they tried to dump the memory contents of those custom virtual machines or try to inspect what they're doing inside the CPU, they're only going to see encrypted contents. And those contents can only be unlocked with keys that are only available to the CPUs. So that's how we kind of do the isolation between the two. We complement that with a technology called attestation. This is really how a customer at any point can essentially query the hardware, obtain assigned evidence from the hardware, which is then provided to an attestation provider. Today, it's Microsoft Azure Attestation. Intel do also have their Trust Authority product that they're developing for a kind of third-party oversight of this, if you want to put it that way. That attestation verifier checks the evidence, and it will basically return the evidence back to your application to make a decision. Now, this really happens in two stages. Firstly, whenever we boot a virtual machine or a container within confidential computing, we do this attestation check ourselves in the background. So we can ensure that those workloads only ever run on hardware that receives confidential computing. And then, as I described earlier, you as a customer can do that check at any time. Now, the reason I think that's important is there's a kind of like default protection you get from the platform. And then if you need within your application to make a conscious decision before you do something to check you're getting the right level of protection, you can do that with an attestation check. So the simplest example I have for that is, I have a customer who has essentially a release pipeline. There are some secrets when they want to release that encryption key inside the VM. They can use what we call secure key release. They can combine this with managed HSM, where the managed HSM will essentially check the evidence based on a policy that's been provided by the attestation provider to release the key. So it means that if someone were able to subvert this workload and run it on hardware that doesn't have confidential computing, it would be prevented from running, and that workload would not receive the encryption key. And it moves just to this model where essentially logical isolation, which is what...
Just a short question for people that don't understand what an HSM is. Can you explain that?
Yeah, sure. So an HSM, or a hardware security module, is typically... So that you can buy your own, that you've put in your own data centers, but within Azure, we have Azure Key Vault as our kind of software-based key protection mechanisms, and it runs up in a kind of hierarchy really to kind of managed HSM, which is the top tier of that stack, which is essentially an HSM where Microsoft give you a partition of that HSM where you can manage the security boundary where the keys are, but the principle is that the keys are protected inside that HSM. And basically nobody has access to those keys. You can release data from the keys, but only based on certain conditions being met. So it's a really, it's kind of industry standard way really of protecting very sensitive data like encryption keys and credentials for applications and systems.
Yeah, and what I'm seeing at the customers where I have the possibility to work with software entity is that they also have to set it up in a corresponding way, and that's the how do you say that, the root keys to unlock the HSM, that there needs to be a process or at least some things in the organization, because if you lose those keys, then you have a big problem.
You have no access. Yeah, I mean it's those are the kind of keys that you maybe put in a safe, for, or in another kind of vault on your premises. Is sometimes we see that use case.
Okay,
cool. So it gets us this model where kind of on the left hand side, logical isolation is what Azure has really had today, and actually many kind of systems like this that we use kind of trust-based software isolation. So it's a combination of using software things like role-based access control, network segregation to ensure that customers are separated from each other, combined with oversight from controls and regulators, and reading those Azure Trust Center reports. Whereas on the right-hand side, what we can now start to provide with confidential computing is really start to provide the equivalent level of kind of physical isolation. I mean, we do have some customers who really want that their hardware only runs on one particular server within the Azure platform. Now that is technically possible in Azure. We have Azure Dedicated Host, for example, but really that doesn't scale very well for most customers in the public cloud. So we can start to use those encryption boundaries, those trusted execution environments, as ways of combining multiple customers onto shared hosts, but use encryption as a kind of hardware enforced encryption boundary between the two. So you can essentially end up with, the best of both worlds. You get all that logical isolation. We can now layer on a degree of kind of physical isolation through encryption, but we can do that on shared hardware, which is really important for a kind of cloud provider. And really just to look at what that looks like at a technical level, right? So today, a kind of general offering that most consumers are using is technology from AMD, and TDX is coming up as well. Sorry, Intel's TDX product. So this really means that we can have an entire virtual machine. So all of its operating system and everything encapsulated. You can lift and shift that VM unmodified. We will be supporting Azure Migrate, for example, but you can have a standard virtual machine. Your application inside doesn't know it's running on confidential computing. It's similar to the kind of early virtualization. That is just a black box that you put your application into, but it automatically gets encrypted and it's transparent to your applications and your consumers.
So basically you are encrypting the whole virtual machine together.
That's right. Yeah. So, I mean, one kind of caveat that we do, there are a subset of virtual machines we support, and it's generally the later, and it has to be a generation 2 VM, but we have a fairly wide selection of Windows, Ubuntu support, Red Hat is also coming along as well. And as those kind of kernel changes have been upstreamed into a lot of the other open source vendors, we do expect to start seeing many of the other open source operating systems turning up with support for confidential computing. And there's a combination essentially of a number of different technologies. So the hardware root of trust we talked about, those certificates that are based into the CPU and the CPU security processor. The attestation piece we talked about. Trusted launch is now actually default across the whole Azure platform, but this is really technology we have built into the underlying platform that we can use to prevent any kind of boot or rootkit type scenarios with software trying to subvert the boot process of a virtual machine by injecting malicious code. Memory isolation encryption we talked about, and we combine that with this secure key management process that I kind of alluded to earlier, where we can ensure that we only ever release sensitive data like encryption keys to machines when they can prove through attestation that they're running with the protections of confidential computing. It's worth talking about where we think this is. Slightly wrong slide. Just briefly where we see this as being in the industry, right? This kind of circle is what I have typically worked with many regulators over the years, right? And they start looking at kind of new technology to market, understanding how their customers are applying it, and ultimately it ends up in a kind of requirement phase. So if you're thinking about encryption at rest, it's already been around this cycle, right? You'd have a difficult time arguing with a regulator today why you don't encrypt data at rest, because the technology is ubiquitous, it's easy to adopt. And we're really starting to see confidential computing now turning from that kind of asking in learning into suggesting. We've got some active regulations we can already see from various global regulators that either make direct or slightly indirect, but meaning the same thing, requirements for the usage of confidential computing. And as privacy requirements become much more stringent, and we've all seen this probably over the last 2 or 3 years, really take an uptick. This is really where we see customers now starting to feel the need that they will need to go further than the standard protections they get to do further things to protect customer data. Now, we, as Microsoft, are doing this ourselves as well, right? We announced a little while ago our Secure Futures initiative, which is really where we're doing, further work to harden the Azure platform against, future kind of more complicated attacks. And really, confidential computing is kind of a key part of what we're using to secure some of our identity solutions within Azure and various other bits and pieces of the platform. So you see there's a customer demand for this, which is coming up, but really, we're trying to take a really proactive approach as Microsoft to make sure we've got the best level of protection for our customers in place. It's also, it's not something new to us, right? We've been using confidential computing for a while, right? So actually our payments service, so I think all the services that handle things like Xbox payments, for example, have been using technology based on confidential computing for a long time. We have options for desktops even, to use confidential computing, and we're starting to expand it out into other services. The kind of work we're doing with some of our identity services is really key to how we, as a very high value target, are taking the kind of industry leading steps to make sure we've got the best security wrapped around our solutions for customers. Now that's the very kind of quick version of, maybe not so quick, but of what confidential computing is. But where I said at the beginning that this is really today a kind of opt-in technology in Azure, right? This is really the state of where we currently are. So, I'm part of Azure Core. We kind of live down here at the bottom where we're enabling getting hardware into data centers that support confidential computing. And we have a variety of options today using Intel, AMD hardware, as well as NVIDIA. We have the ability to then layer container services on top of that for AK. So we have options today for AKS and ACI, which we're going to demo in a moment. And then we have a fairly narrow portfolio, I guess, of kind of what we call first-party services. So things like PaaS services, like databases. You'll see here SQL and Databricks, for example, that sit on top of confidential computing. I think up here is really where we see a kind of big growth area. We've got demand from customers who are looking for services to be able to run confidential end-to-end, which means that this, our kind of services portfolio up here needs to be expanding. So this is really where I think we've got some kind of focus quite heavily at the moment.
I think that is one of the questions I mostly get, also from the community, which I've set up with a colleague of mine. The question mostly is like, how can I make it end-to-end from start to finish until it's in the database through the application? Mm-hmm. So that question still lives.
Yeah, and there's a lot of effort internally going into expanding out the work that we do, and it's not something I can necessarily talk about directly in terms of roadmap or plans or timelines, but there's definitely a lot of work going on in this space.
Definitely. Are there specific topics which is coming, or is that not being possible?
I would keep your eyes open for upcoming events. That's probably the best advice I could have for that.
Okay.
So, but it is important to kind of temper that with where we are today as a product, right? So we do have a robust product, right? People are using it. We have real live large customers on it to do today. But it is important to today we do have a performance overhead for using confidential computing, right? It can vary based on the solution that you're putting on it, right? There are things like if you have really high dependence on network or disk, you'll typically see a higher performance overhead today. If it's purely CPU bound, it's generally pretty efficient. But obviously the hardware and the engineering that's going into that is looking to, certainly the roadmap for that mitigates that fairly well. We are also in a limited amount of regions today. I think it's currently 14 or 13 regions globally for customers. We are pushing actively our hardware into all regions. So we certainly anticipate sort of later this year being in all regions globally. That doesn't necessarily mean that will all be available for customers for day one, but if there is interest in certain regions where we don't currently have that, if you work with the Microsoft team, we can look potentially where there are options to prioritize some of that. Site migration, backup, obviously two key features for the virtual machine side of the house. Those are things that are actively being worked on, and there'll be some announcements, I'm assuming, coming up on those fairly shortly. We do also today, and whilst we don't necessarily show it on this slide, we don't currently have support for what we call live migration in the back end for things like confidential VMs. So this does mean that right now customers could potentially anticipate up to kind of 2 reboots a year whilst we kind of redistribute load. That is something that's being actively worked on. But again, he's trying to get it's quite complicated because of the way the encryption domains synchronize across hosts, etc. So there's a lot of work going into that. And I guess just to kind of close out that briefly, the GPUs are a new offering, right? So today it's kind of fairly limited in that you can have one CVM with a GPU paired with it, but it means you can build a really kind of a really complicated solution that does a lot of stuff, but purely inside the trusted execution environment. So the newer GPUs that are coming out from NVIDIA have the similar ability to the CPUs, so you can deploy data and code into those. They can do their integration, but you can ensure that it's always protected end to end as part of an application. And really, this is our vision. So I think we, as Microsoft, Mark Russinovich has said publicly a number of times, I think this is really where we see the logical conclusion of everything in the public cloud going. Right, we've already done it for at rest, we've already done it for in transit. This is that kind of last barrier, and really it's to make sure that data is always in control of the customer, right, through all of its lifecycle states, as it lives in a cloud platform. Secondly, we as Azure don't want to be in your data, right? There's no benefit to Azure to have access to your data, and you obviously don't want Azure to have access to your data. So this is something we want to make sure we use confidential computing as a technology to ensure that there's a very hard kind of boundary between the two.
I think this is also mostly what we're trying to share. Like, this is one way to also push the cloud provider outside of the chain of trust. Mm-hmm. Not meaning in a bad way, but that you have full control over your data, basically.
Correct. Yeah.
From start to finish. Yeah.
Yeah. I mean, we're not in the kind of business where we want to monetize your data, right? There's no benefit for Azure to have access to your data. We're quite happy to host it, and we want to make sure that you've got the right level of trust for your workloads that are running there by isolating it to yourselves. And then we can combine all of that technology that's coming for confidential computing to do all that kind of verification by the customer, that kind of attestation process we talked about earlier. But also, today we have things like Confidential Ledger, which is a technology based on confidential computing, which you can use, which is built on kind of like a blockchain technology backed by confidential computing to give you a full kind of immutable audit logs. For anybody who's ever had to answer that question of, could someone have modified your application logs? This is potentially one way that you could do that. And then as we look wider across the Azure platform, you can see there are a number of other potential opportunities for doing that. So that's the kind of the core of the kind of content. We're doing some work right now with some service provider customers. These are typically our larger kind of confidential computing customers today, and they, we talked about the kind of sovereignty points earlier. There've been some recent announcements around this as well. Confidential computing is really kind of a key part of delivering the promise of that for these customers. With that, I appreciate I've kind of rambled for quite a long time, and I'm quite happy to flip over to a demo if that's probably.
We are very curious to the demo, yes.
Okay, let me just switch the screens here.
Well, at least it's a very promising technology, and I've also worked with customers already using this into the field, and it really helps in getting the trust, but also giving them the possibility to have the full control, basically.
Sure. Cool. So hopefully you can see what I'm sharing. I've done that around the correct way this time.
Yeah, and a little bit bigger, that would be great.
Okay. Yeah. So firstly, I'll share the links for this so that you can put them, I guess, in the notes, right? So I think the first place to start would be, we've got a Git repo. We are moving around a couple of the Git repos. This one here is going to be I think the de facto one where we're going to put everything. So this has got our current set of samples for Azure Container instances, for AKS, and also some virtual machines. So that's a really good place to start. So what I was going to show first, and I guess I'll just make this a bit bigger as well then. So what I've got here is a virtual machine. So this is a confidential VM. Now, what you will see here, and all of the confidential VM SKUs begin with DC or EC. Okay, and that's kind of an important thing to note. if you're deploying a whole VM, confidential VM, it will be one of these DC SKUs. And then the A would indicate that it runs on AMD infrastructure, and there's a different code for TDX. So what we're going to do here is we're going to connect to this. I'll just show you briefly what this is. So this is really just a Windows Server VM, just a standard gallery image that we've deployed. I mean, at the moment, I've got it on a private IP address. It is configured with confidential disk encryption, which we didn't talk about in a huge amount of detail, but this is essentially the disk itself is wrapped. The disk is on Azure storage with a platform managed key. Then inside the VM, it uses what we call confidential disk encryption, which is essentially customer managed key held in Azure Key Vault Premium in this instance, or you could do it with managed HSM, which then provides the key to BitLocker inside the VM. So, and then what happens is when the VM boots, the keys will only be released to the VM if it can prove that it's running on confidential computing hardware. So it kind of guards you against the scenario of, some attacker trying to move your VM onto other hardware where maybe it has the ability to kind of do some kind of inspection. This is a way of hard enforcing that even if that were to happen, the keys would not be released to that VM. You wouldn't be able to log into it.
Are the keys being transferred over the line? That's a question I mostly get.
So the key. So in this case, because it's using confidential disk encryption, essentially what happens is the keys are only decrypted. They're encrypted across the network, but they're only able to be decrypted inside the trusted execution environment. So inside that kind of black box inside the CPU.
But then the question is, if I could sniff in between the HSM and the conventional VM, could I then catch the key, so to speak?
Yeah,
that's a question I mostly get.
Yeah, so you can't do that. And even if you were on the Azure host itself, trying to do that with some kind of in-memory or bus inspection, you still wouldn't be able to do that because the key only gets decrypted once it's inside the T in that confidential disk encryption model.
Okay.
So what I'm going to do here is just connect to my VM just using Bastion. This might take a minute or so just for it to spin up the connection. And as you'll see, this is just a straight VM, right? There is literally nothing special about this VM. And unfortunately, it rebooted overnight, so it's now lost my demo that I had running. So give me 2 seconds. Okay, so in our Git repo, we essentially have a script, and that script will run the attestation process inside the VM. Now, I'm going to have to cheat slightly here because, I say, it rebooted since I set it up last night.
Well, maybe also this year you can maybe enlarge a little bit. It's very small.
Yeah, this might be a bit difficult in here. In fact, if I show you in the script view, that's probably easier. So basically, there is this script here, and this is really just you can download this to run it. So there's a script in this repo that will deploy a confidential VM with all of the so in here, this script will deploy a confidential VM with all of the key vault, set a random password for it, etc., and get it to use confidential disk encryption. It will then also run an attestation process inside it. Now, I'm going to run this in the VM just so you can see the output of it. I'm just going to take these commands here. Okay, so the script basically will check something, but the easiest way to see this, if I'm going to have to make this bigger then. Okay, so I know this is quite technical, but this is essentially the output from the attestation. So once you make an attestation call, so it's taken the evidence that it's got from the CPU, and it's now presented that to the attestation service. So you'll see I'm using one of our shared attestation endpoints here. You can have your own private attestation endpoints if you want to do that as well. And if you look, for example, for some of the properties that come back, you will see compliance status that says it is a CVM. You can see that it's using SEV SMP hardware, and it also gives you a whole host of data here, which is really around the microcode that's running on the CPU. Additionally, you can see here whether the hardware debugger is turned on. Now this is this is disabled for CVM, so this is another way that you can check this. But you can use the policies that come back here and the signatures as a way to validate your CVM is running where it should be. You can also use the data that comes back from this. If you had an individual requirement that you only wanted your platform to run on microcode of a certain version, you can code that into your attestation policy here. So it gives you, as a customer, a way of, whilst Azure may do some things around the back, you can make sure that your hardware is always running on microcode that you trust.
Right. So a sort of verification, and if you want to make it custom, so to speak.
That's right. So that's right. I know it's not a very whizzy demo, but what you could do is then build the output of this into a script for, say, which for that customer I have that does some build pipelines. When they run a certain point in their build pipeline, they will also make an attestation check. And as long as it passes the attestation check, they will allow the build pipeline to continue. If for anything has gone wrong and maybe someone has tried to deploy their workload onto a standard VM, or even just trying to do it somewhere else in maybe another cloud provider but has managed to deploy their application, you can use this attestation check as a way of preventing that from running, and you can build that into your own application. So one of the other options we have are container instances. So for anybody who's not used Azure Container Instances, it's our kind of serverless container offering. It's a really easy way just to take a standard container, spin it up, and run it in Azure. So I'm just going to show you what the experience of that looks like. Okay, so I'm just going to put that into a new resource group. I'm going to call the container something random. I'm spinning this up in East US, and obviously bear in mind we only have specific support in specific regions. I know we are available in East US, for example. The important part here is on the SKU parameter. You will see we have the option of deploying a standard SKU or a confidential SKU. Now, the demo I'm doing here is with the development policy. There are some more advanced options which I'll give you in the documentation that you can use with a tool called ConfCom, which you can then use to define policy. And the really cool bit about container instances here is that you can define in the policy that your container can only ever run certain container layers, or it can only run certain commands, and it really allows you to lock down people's ability to exec to the container. So if you've ever had to work with kind of sealed applications, if you want to think about it that way, we can use this because the ACI container itself is protected from everything around it. We can use the policy, which is tied to confidential computing here, to block it from ever actually having prevent anybody from execing to the container, and we can do that with the policy, and we can bake that policy into the release pipeline for the container. Now, I'm just putting in a really simple container we have here to demo this, and what it will do is once it's provisioned, it will come back and show the output of the attestation. But you could obviously extend this to any application. You can deploy any app you like onto ACI. So I've got Blog, which I'll give you the link to, where I take a Minecraft server, so literally a community contributed Minecraft server off the shelf, no modifications, and I can deploy that onto ACI unmodified. So just while this goes through and does its thing, and then we'll look at what that looks like.
Did you also work with Coco, the confidential?
So that's, so we've got kind of three offerings today, right? So we've got kind of AKS, AKS worker nodes, which we're going to look at next. We've got ACI, and then there's some future work that's in preview at the moment on what we call confidential containers, and that's really the kind of Coco work. That is the best way to think about it. It's the best of both worlds with ACI in that it's just your container that you trust. but meshed together with the capabilities of AKS.
Indeed, yeah. It's amazing, and it's even a step further into the stack, if you want to say it like that.
Yeah, and it's so what we tried to get to is what we call the TCB, or the Trusted Compute Base. We try to make that as small as possible. So the goal with confidential containers is we will just get that down to the container, whereas obviously AKS worker nodes today is the worker node and all of the containers that sit on top of it. So you'll see that has spun up. If we just look in here, you will see that is running. Now, I haven't got the development policy allows me to connect to that container. So, for example, I can make a bash connection here. I can write into the policy to block that. And if I were doing that at this point, it would say that it's blocked by policy. I can also get more granular. I can essentially block certain commands being run inside that container. So I can stop someone running netstat, for example, inside the container. And similarly, I can control where all of the logs for that container go. So that's that policy, which is encoded. So I can now, you will see. So this is that very small text of the container that I just spun up. So this is just a very simple demo, but it is showing you, for example, the policy that's attached to it, and a whole bunch of data here for the measurement and the host data, which is stuff that you can use with the attestation service to correlate what's going on inside your container. So it's a very quick way of taking an existing container and spinning it up using that. Like I say, you can do this with any other application you like. I had a demo doing this with WordPress in the past as well. So the other option we wanted to look at was AKS. Now AKS is a little bit more complicated, but to get you going, there is a kind of starter sample here, which will build, if we get down a bit further, this will build an AKS worker node cluster. So it's essentially a set of worker nodes. So this is a AKS cluster which is built with worker nodes. So you will see, if we look under node pools, I've got two node pools. So there's the default node pool and there's an extra node pool I've added to it for using ACC nodes. Now, in reality, both of these are actually using ACC. So the node pool itself and the additional node pool, which is running confidential computing. So you can see here, these are running those DC. So D series VM, C for confidential, little a for AMD nodes. Okay, now the scripts here will build that Kubernetes cluster. So what I'm going to do is just to demonstrate how straightforward this is. This is actually, like I say, it's a standard AKS cluster. I'm going to use a Helm chart to deploy one of our sample applications to it. I'm sure you'll have seen this. This is the voting application. We'll just wait for the to get an IP address. The point here being this is a standard application, nothing modified. It's the same application we use everywhere else, but I've now deployed it onto AKS. So it's now got its IP address. Okay, and I'm sure you've seen the voting application once or twice. But this is running in confidential computing, right? So, and what's happened here is we've got the worker nodes, which are running essentially confidential VMs. The containers are running on those VMs. And so from a kind of threat scenario point of view, if you were to look at it that way, what we're trying to protect here against is, this we typically see this in a kind of sovereignty scenario where you as a customer want to make sure that the cloud provider does not have access to your workload. So this is the typical kind of setup we see for those type of scenarios.
All right. And the application is still accessible, right?
Yeah, and like literally, I can still use all of my same, I can still use nodes. So I can still see my nodes. I can still interact with it in exactly the same way. This is just standard AKS.
Cool. Well, I think that rounds it up for our conversation. I'm seeing we're running out of time. I think we can talk hours and hours, but thank you for the great demos. I think it's also giving a perspective that it's not. It was a lot of theory, but also combined into the technical point of view, how you can make it work, basically.
Sure.
So that looks amazing. Thank you very much. Maybe last question. If you look back and people are just getting started, do you have some tips?
Yeah.
Or do's or don'ts?
So I think the Git repo is a really good place to start. I mean, whilst you can use the PowerShell commands that are there to get you a fully built CVM, you can also take those individually. I will also give you the link to the AKS doc site, which is really good. We've got a lot of quick start examples to get going. But I think the thing to think about it is it's not something. Confidential computing used to be something you had to build applications specifically for. I think we're really at the point now where we can just take off the shelf applications, make them confidential, right? And that's really where we want to get to. So the doc site and the Git repo are a really good place to start.
Okay. Let's do that. We will paste them beneath this video so that you can take a look in a later time or when you're listening to this video. For now, Simon, thank you very much for your time, also for your explanation and the great demos. Hopefully, I can invite you back when Confidential is even further from this stage on. Is there a sort of roadmap that is available nowadays, or we have to follow build?
So I would just keep watching the events for announcements as they come up. So the Secure Features Initiative report, I can give you the report to that as well. That's quite an interesting one to read, because that will certainly talk in a little bit more detail about how we as Microsoft are using confidential computing as well.
Okay, thank you very much.
Cool.
For everybody who's listening, thank you for your time, also for listening, and till next time, take care. Bye-bye.
Thank you.